This is a talk on picamera, which is a Python library, pure Python library for controlling the Raspberry Pi camera. First question, well, actually, let's find out how many people here have got a Raspberry Pi camera? Oh, lots of people. How many people here use Python? No, okay. So, how many people use IPython? Not IPython.
I think it's 9.
No, interesting. You're going to like this a lot. Not so much for the camera, probably, but for the IPython bit, certainly. Right, so question first of all, why on earth would you use picamera to control your camera when you've got Raspberry Still and Raspberry Pi? Well, major reason is these are monolithic programs designed for scripting. They don't offer much interactivity. So the general way you go about using Raspberry Still and Raspberry Pi, you set it off with a bunch of parameters, brightness, contrast, whatever you want to do, tell it to take a picture in 10 seconds. But once you've set it going, that's it. You don't have the opportunity to say, hang on a minute, no, users change their mind, I want to do this instead. Now you've got to terminate the program, restart it. The idea of having a library is it allows you to interact a lot more easily. So that's basically what we're going to do here. We're literally going to sit down and see exactly how to use it. Just a whistle-stop tour of the library. So first things first, installation. Spell. Now, so, right. Hopefully everybody can more or less see what's going on the screen there. Downloads, unpacks, and we're installed. Right. So, IPython. You'll love IPython. Wonderful stuff. Brilliant for exploring libraries. We fire up IPython, and we import picamera. Now, first thing we're going to do is construct a picamera instance, like so. And hopefully, you should see a little light coming on in front of it. Yay, we have a light. So, what can we actually do with the camera object? Wonderful things about IPython. Camera dot tab complete. Aha! Lots and lots of things. Well, we've got something vaguely interesting there called start preview, so let's see what that does. Can you see your ugly mugs on the screen? You're upside down. Okay. We're upside down. Well, let's see what we've got. We've got leaflet. Sounds vaguely interesting. Another brilliant thing about IPython, if you want to find out what something does, we could go and read the docs at this point, but that would be looking something up online. If we put a question mark at the end, we go, what is that? Aha! Whether or not the camera's... No, it's a bit wrapped because I've expanded the screen, but generally speaking, you should see all the actual stuff there. So you can see it's a property. Retrieves or sets off the camera's output, vertically flipped, returns the boolean. Okay, fine. So we go camera.vflip is true. Hopefully you're the right way up now. You're probably backwards though, so let's do an H-flip as well. There we go. And we've got a few other things there. We're all horribly washed out. And there's a whole bunch of other properties that we could look at, such as if we want to see some text through your faces, we could make it semi-transparent. So, basically this allows us a certain amount of interactivity with the camera. It allows us to change things on the fly, and this allows us to build an interactive application relatively easily. In fact, that's what the second talk will be about this afternoon, on building a web-based application for controlling the Python camera. Now, plenty of things we can play with here. As you can see, we've got all sorts of resolution and frame rate and so on and so forth. We can set up the camera to do all sorts of things. We were, in the previous talk, just mentioning setting up the camera to shoot in low light. One of the methods you can do is exposure night, which probably makes that go relatively slowly on the screen now. Move out. If we want to know what exposure modes, we can go and look at the exposure modes property. There's one there called auto. Back to that. So, plenty of properties. How do we actually use this to take pictures, though? Record video, do useful things. Now, there's several interesting methods up here. Capture continuous, capture sequence. Let's have a look at capture. What does that do for us? So it's a method. Captures an image from the camera, storing it in output. Okay, so we've got an output, format, bunch of options. If output is string, treat it as a file. Otherwise, treat it as a file-like object. Okay, let's try that. Let's take a picture of you lot called who. Aha, you should now have This is the other lovely thing about IPython. We can just drop to the shell and say, what's in my directory? Ah, food object. Right. So hopefully, if I grab the Python imaging library at this point, we should be able to open that and show that on the main monitor. Let's open the food and show that. Fingers crossed. Aha! Picture of the audience. Excellent. Right. So that's capturing individual images. As you can probably tell, it's running at the resolution of the monitor here. We can use all sorts of resolutions, and the Raspberry Pi's camera is actually quite high res. We can go all the way up to 5 megapixels. So we can now capture a very, very high resolution image and show that. And once again, we should see. Let's go take a little while over the net click. Oh, come on. You can do it, little laptop. That is chucking quite a lot of data over the network link here, unfortunately. Oh, God. That is an enormous picture. Whoa. Yeah. So we've got quite a high quality camera that we can do some fairly interesting things with. What about those other capture methods that we've got there? Well, you did mention that we can use not only a file name, but a file-like object. It just so happens Python has a lovely thing called bytesIO, which is an in-memory stream. So we grab stream, and then we can capture the lat. This means we avoid dealing with the disk at all. If you don't actually care about storing the image and you just want to do some processing on the image, then all of a sudden you're free from having to worry about permissions on the file system, whether or not you're going to run out of space. We can just capture straight to the stream. Of course, the stream has no file name, so it doesn't know what format we're going to capture it. So let's give it a format. Let's say format to JPEG. So now we capture that. You should find the stream has quite a lot of data in it. It's 2.5 megs. So what we do is we would rewind that. Actually, I'll tell you what, because that one took so long to open, let's do that at a slightly more sensible resolution. Let's rewind to the start of the stream and truncate it. And then capture that again. And now, our stream should have a reasonably sensible amount of data in it. There we go, 0.5 meg of data. That's a bit more like it. Let's rewind it to the beginning. And again, with build, we can just open the stream and show it. And here we have, hopefully, let's go. One minute. Okay. So, let's have a look at a couple of other things. What do we want to capture a sequence of images? We can just give it a sequence of image 1, image 2, and image 3. And that should allow us to capture 3 images straight off the disk. There we go, image 1, 2, and 3. These are doing relatively quick shots. And we have capture continuous. Capture continuous feeds us continuous images from the camera in a loop. And that allows us, because we're in a loop at that point, we can insert delays if you want to do time-lapse photography, for example. So we can go for file name in camera.capture continuous, and we can give it image counter JPEG, and we can print file name, and then if the file name equals, let's say, image3.jpg, and we're going to break out all of it. And here we capture 3 images. And you can quite easily see how we can insert a delay into that loop to say, take a picture every hour, for example. So that's capturing. And very briefly, because we're running out of time, we also have start recording and stop recording. So let's just very quickly do some of that. Wait for me. Okay. There we go, stop recording, and that is literally capturing to a file as well. And again, we can do that with a file-like object. So yes, this is basically how to use the picamera library, and when you're done with it, final thing to do is close. Yeah.
Sorry, I lack of time.
No problem.